Emostel.
Hello, you are welcome to this video. Now in this tutorial, we are going to be talking about something also very important. We've spent the last couple of videos, about 8 of them, talking about graphs. So now the next couple of videos is going to be talking about measurements in physics. Something very important. It's going to even help you beyond physics. All right, so what is it about measurements? Well, the first two things that we're going to be talking about in this topic of measurement is the possible error and then precision and then relative error and accuracy. But then before we get to all this, and even before I start to talk about this diagram that you're seeing behind me, okay, there is something I want you to just understand. You see, in physics, we don't joke with numbers. We don't joke with numbers. We don't just write numbers carelessly. Well, even I, myself, until I got to learn this thing, that was when I understood, why they asked you to do some things. Why they asked us to do some things back then in secondary school when we were doing physics practical. That time they would say plot a graph of t squared against L, and I was like, okay, so why not t against L? What is the square doing there? Until we got to university, and then we got to understand the reason why it is t squared. So, and I know many of you are just getting to know all this too. Okay, so on a similar note too, you are going to understand the reason why some numbers are written the way they are. Why, in physics, there is a difference as far as physics is concerned. There is a difference between 1.2 and 1.20. Even 1.200, it has meaning. You don't just write all these numbers like that for no reason. You write them for reasons, like they are very significant, and you are going to learn about their significance and about a couple of things concerning them, either in this video or the next. It depends on the length of of the discussion. Okay, so now why do we have this? What is the difference? Mathematically, there is no difference between the three, but when it comes to physics, or especially in terms of representing the result of physical experiments, well, there is a difference between them. Okay, fine. Without much ado, I really want to talk about the things that led to this difference that I'm talking about. All right? Okay, so just follow me. The whole story starts from something like this. Okay, what you are seeing here is a ruler. What you're seeing here is like a ruler, okay? The reason why you have this zigzag stuff here is because this is not the full length of the ruler. It's only the part of the length of the ruler, okay? Like a magnified picture of a ruler. That is what you're seeing, like a measuring ruler that you can use to take measurement of centimeters and all that. You get what I'm trying to say? Like a magnified version of it. That's what you're seeing here. And then this zigzag stuff is because, well, the ruler is longer than this, but it just took a part of it and then a part of it, okay, just to tell you that it's just an approximate representation. It's not the full length representation of the ruler. That's what this thing means here, okay? All right, so let's just ignore this part. Now, let's assume that you have like 3 arrows, like, okay, you want to measure 3 things, okay? So these arrows that you have here, they represent some form of measurements. This is the head of the arrow, okay? So ideally, it should have been written like, okay, this is one measurement. Maybe it should have been drawn outside the ruler, just like following what the course material drew. If I have my way, I would have actually drawn them outside the ruler, okay, that this is a particular line. You want to place the ruler there to measure the line, okay? So this is a line, a long line coming from somewhere, and then the line reach this place, and then you trace the measurement down to the ruler. Okay, then you have another line like this. You can call this one line A. Then this is line B. okay, of which you can trace. You can trace the measurement to the ruler like this. And then you can take this one, the third one, which is line C, like this. Line C. And then like this, okay? So as such, you trace it down to the ruler, and it balances at this point, not exactly on the other points, okay? So, but somewhere around here, not exactly on this point, okay? So now let's say on the ruler, this is, so which means we don't need this line, okay? Let me just take the line away. Let me take it away so it doesn't confuse you. I've drawn it outside the ruler already. All right, so, which means, okay, good. So this point still remains, this point 4.3, this point here 4.2, and then you have this whatever, like a point before the 4.3, a point before the 4.2. So a point after the 4.3, 2 points before the 4.3. So now, so let's say this is a length, and you trace the edge of the length to the ruler, and then the thing balances at these points. So we have the point A, it balances, it reaches you trace it to the ruler at this point, and you take the measurement. Remember that this is a ruler, okay, please, and the ruler is what do they call this thing again, sir? Is graduated, okay? We call it graduation. Those lines that you see on top of any measuring instrument, those lines, we call them graduation mark, okay? Graduation lines or mark, okay? So now, this thing is graduated in centimeter. Like we have this whole area in centimeter. We have 1 centimeter, 2 centimeter, 3 centimeter. And then you know that if we have something like this, maybe this is 1 centimeter, then you have like 10 tiny lines, and then you have 2 centimeter, okay, 10 tiny lines, and then you have 3 centimeter, because the tiny lines are 10 in number on this particular instrument, okay, on this particular measuring instrument, then it means that 1 unit, okay, each unit is 1, okay, we have 1 plus another 1, 2 plus another 1, 3, so we have 1 centimeter, but in between, the smallest division that you have on that instrument, the smallest division you have on that instrument is 0.1, all right? So the main division is 1, plus another 1, 2, plus another 1, 3, but the smaller divisions is 0.1, plus another 0.1, you have 0.2, plus another 0.1, you have 0.3, 0.4, 0.5, 6, 7, 8, 9, and then before you now have another one again, okay? So the moment it's about to turn to 0.9, then 0.10, you know, there is nothing like, it instead of 0.10, you like add 1 to the number before the decimal. So that's why you have 2, and then it goes on and on. So this smallest division that you have on your measuring instrument is what we consider as the units of measure. The smallest division that you have on that measuring instrument is what we call the unit of measure. I know for some of you that have read your course material, you'll be wondering, okay, they just make mention of unit of measure to be 0.1, but why is it 0.1? This is the reason why it's 0.1. It is just the tiny division on your measuring instrument. For other measuring instruments that have maybe like instead of 10 points in between another one, okay, so some of them may have 5 points in between another one. In that case, now you say the unit of measure is like 0.2, okay, because after 0.2, 5 of it will now lead to the next number, okay, but because 10 of these tiny things is what leads to the next number, so which means each of the tiny ones is 0.1, so 10 of it will now lead to a full unit. You get what I'm trying to say? So that's as for that. So that tiny stuff is what we call the unit of measure for that particular measuring instrument, ruler in this case. Okay, good. So now, as you have it this way, this is 4.2. Okay, let's say the thing has started from somewhere 1, 2, 3, 4, and maybe exactly this place is 4 points. 4 maybe 4 something, but the example here is just that, okay, this tiny stuff here, these tiny lines is what was magnified. So it's as if the major one before them is 4. Then we now have 4.1. This one 4.2. This one 4.3. So, but we now zoom it. We zoomed it to become bigger. That is how we are now have this thing, 4.2, 4.3, 4.4. You get that package now. So like we are referring to these tiny lines, only that a magnified version of it is what we have in this picture. So you get it now. But now, what we are actually discussing here is that we are trying to find out, we are trying to determine the possible error. That's what we are just trying to determine. We just want to know, we want to find an estimate for the maximum possible error. When you are measuring, taking measurements, and your measurement falls on a particular point that is not graduated. Are you with me? When your measurement falls on a point that is not graduated, then you have to use approximate values to conclude on the actual measurement, to conclude on something that you can regard as close to the actual measurement. Am I communicating? Let me explain. This is it, 4.3. Let's say, okay, let's assume this is the major, this is major 5, major 6. Okay, you know this is supposed to be 5.1, 5.2. Let's say you are now taking a measurement and the thing now falls in somewhere like this. It falls somewhere in between 5.2 and 5.3. That is what we are having here. We have a measurement that we have 3 measurements falling somewhere in between 4.2, 4.3 and 4.4, but it did not fall exactly on 4.2, 4.3 or 4.4. It falls somewhere in between, just like this. Where you have 5.1, 5.2, 5.3, but the thing did not fall on 5.2. It didn't fall on 5.3. It falls somewhere in between. So you have to use your IQ, you have to use your initiative rather to determine the approximate value of that measurement. You get what I'm trying to say now? Good. So now, this is case A. You see that A, it falls on a place that is much more closer to 4.3 than 4.2. It falls on a place much more closer to 4.3 than 4.2, although it is beyond 4.2. But the place it falls somewhere more closer to 4.3. So we say, okay, we can decide that we can say A is approximately 4.3. We can decide to call it 4.3 because it is closer to 4.3 than 4.2. Or you can now say, you can now say, okay, maybe let's say roughly 4.38, or let's say 4.28 or something. Let's say, because it's closer, let's say 4.28. 4.282 is approximately 4.3. 4.27 is approximately 4.3. 4.25 is approximately 4.3. 4.26 is approximately anything beyond the middle. Okay, anything beyond the center here, which is like 0.05, half of the unit of measure. Anything beyond the half of the unit of measure, we will count it as the next, approximately the next number. Okay, remember that the unit of measure is 0.1. Okay, so the moment the thing that you are trying to check has gone beyond half of the unit of measure, you will take it to be closer to the next value. The approximate value you will choose will be the next value, say approximately 4.3, because it is now closer to 4.3 than 4.2. Okay, so that is it. So we have approximately 4.3 here. If you check B, B is closer to 4.3. It has not reached the half. It has not reached half of the unit of measure. You know the unit of measure is 0.1. From here to here is 0.1. Here to here is 0.1. Here to here is 0.1. Half of it is 0.05. Okay, so that half is what we use to determine the best place that we can call, the nearest value we can relate the number to. Now, if you look at it very well, this is like half of the unit of measure. So, and then this measurement of B falls before the half of the unit of measure, falls somewhere around here. Okay, so we will say this B is roughly 4.3. Roughly 4.3 because it is closer to 4.3 than 4.4. It is the one that it is closer to that we use to determine the approximate value. Okay, if you check C, look at C here. I've painted everywhere. Okay, this is A, this is B, so then this is C. All right, if you look at C, C2 is very closer to 4.3 than 4.2. So you say C is approximately 4.32. So we now have, you can see now that we have 3 different points falling on 3 different places, but yet they are having the same approximate value. As you can see, the one that falls before the 4.3, we say approximately 4.3 because it's closer to 4.3. The one that goes beyond 4.3, but it is farther from 4.4, we still approximated it to 4.3. Okay, so at the end of the day, you will conclude that the last number of this kind of measurements, the last number of every measurement taken in physical experiments, we conclude that that last number, they have tendency of error. We know that the most accurate measurement is still 4. We know unarguably 4 is 4. The problem is the number that follows that 4. After the decimal, the approximate value is where the problem is. You and I know now that based on these 3 things that I just mentioned, A is not exactly 4.3. It is only approximately 4.3. So we see that 0.3 part of it is where the error lies. That's why I circled them. So from these, we were able to, to conclude in physics that the last value of a measurement is very significant, and the last value of the measurement is usually the error value. It carries error, okay? And so, you understand, and then it's only an approximate value. Now, I have not really gotten to where the message is. I'm still going there. But just follow me, okay? Now, as we have gotten to understand this part, that these last values usually carry is the error, is usually the error value and all of that, okay? Now, we move on to something important that I mentioned earlier, which is units of measure. So we now conclude at the end of the day that, okay, the whole thing is existing between a particular, or let me say the key determinants of the final value that we resort to is usually a value around the half of the unit of measure. So everything falls between, if you check all these things, the range of values from here to here, from here to here, you will see that it all falls in between 0.5. 0.5, I'm sorry, 0.05. That is half of 0.1. From R1, from this point to this point, from 4.2 to 4.3 is 0.1. From 4.3 to 4.4 is also 0.1. Okay? So now, just like this, 4.1, 4.2, 4.3, 4.4, like 0.1. But the thing that determines the value that we will choose for it, the determinant of the position of the approximate value is usually 0.05. That is half of the unit of measure. Remember, I told you that for me to determine whether something is closer or not, it is that 0.5 that I will use to measure it, like half of the 0.1, half, like the halfway through. So if the thing is closer to the first half than the second half, then I will approximate it to the number before, to the points before. If it is closer to the second half, to the other half than the first half, I will approximate it to the number to the point after. You understand it now? But that half is we know that, okay, highest, roughly. Because if you can look at this one very well, if you want to determine A, for instance, okay, we can say, okay, based on where A fell, A can be roughly 4.3, let's say 4.36, because it's just a little bit beyond 4.35. 4.26. Okay, that's it. What I'm trying to say is that if you look at where A fell, A falls at, this is 4.2, this is 4.3. So halfway between 4.2 and 4.3 will be 4.25, right? So let's say A fell around 4.26. Okay? Now, if you look at this one too, where C fell much more closer to 4.3. So let's say 4.28 or 29. Then if you look at where B fell a little bit beyond 4.3, but not up to 4.35. So let's say B is like 4.332 or 33, 4.33, but it's not up to 4.35. Okay. So at the end of the day, what do you see? You see that all of them can be approximated. Like this one can be rounded up to 4.3. This one can be rounded up to 4.3. This one can be rounded off to what? To 4.3. Okay. So, but the last value here is the uncertain value. The last value here is the uncertain value. So, which means that the highest uncertainty, the uncertainty falls between the range of plus or minus 0.5. The uncertainty of this one now, is like it falls between plus 0.5. Beyond, the real measurement is 4.2, then it goes beyond 4.25 to 4.2 something. Okay, so we consider it as possible 0.5 then. Okay, let me say it's like, okay, good. 4.3 minus 0.5. That is the highest. It falls between, because it's not exactly 4.3, but it's a number that is before 4.3. Only that we approximated it to 4.3. So the error in approximation, or the error in value, or the error in position will not go beyond 0.5, but negative 0.5, because it is a value that fell before the 4.3 mark. So that's why we put minus 0.5. This one falls beyond the 4.3 mark, but still, so we say this one is, the error is like 4.3 plus 0.5. It did not reach 0.5 finish, but the moment it's past 0.5, we will rather make it to be 4.4. So for it to still continue to bear the name 4.3, it means the balance, or the landing of the measurement falls within a range of that 0.5 beyond the 4.3. 0.5 mark beyond 4.3 falls within that range. That is why we have plus 0.5. Here is minus 0.5. So which means that if I want to say, okay, all these values, I will say 4.3 plus or minus 0.5. 4.3 plus or minus 0.5. So this one gives us the what? The maximum possible error. The highest we can have is either negative 0.5 or positive 0.5, because if it goes beyond that 0.5, we will rather approximate it to a higher number or a lower number. You get what I'm trying to say? So if you see that the 0.5 range is the determinant, that is the reason why they said the maximum possible error is what? 0.5, which is the half of the unit of measure. So for a ruler that is graduated at, for a ruler or a measuring instrument whose unit of measure is 0.1, then we conclude that the maximum possible error for that measuring instrument is 0.5. I'm just trying to rush, because this is a revision class, and I don't want the video to be too lengthy. If it is what's a class, a normal class, I would try to make it more practical, and then we will all do it together and for you to see. So I'm just trying to paint as much as possible the real life situation, but yet I'm still fighting against time. Okay, so, but I believe that with what I've explained, you understand the reason why we usually have this thing, plus or minus 0.5, because we are still going to be dealing with something like this. Not 0.5, but 0.05, sorry. 0.05. Because 0.1 is the unit of measure, half of it is 0.05. Okay, so that's why we are having something like 4.26, 4.3, something. It's either a little bit less than 0.05 to 4.3, or a little bit higher than 0.05 to the normal 4.3. So if it is a little bit less than 0.05 to 4.3, just like 4.26, then we say minus 0.05 is the highest, is the lowest error, or the highest error value, rather, the maximum possible error. Then, but negative, but backward. Then here, it goes a little bit beyond 4.3, but it did not reach 4.35. Because the moment it reaches 4.35, we say it's approximately equal to what? 4.4. So it will leave the territory of 4.3. You understand it now? So the maximum possible error is still 0.05, but it is plus 0.05 because the real measurement is beyond 0.05, okay? It lands beyond 4.3. So because it lands beyond 4.3, but it did not exceed 4.35. So that is why the maximum possible error here is positive 4.35. Positive because the measurement goes beyond 4.3. We only approximated it backward to 4.3. You understand it now? Here, it did not reach 4.3. We only approximated it forward to 4.3. So that's why it's as if it is owing to reach the place of 4.3. This one is having excess. We understand it now to still be on 4.3. So that's why we have the minus or plus. But that is the reason why they usually write that, okay, the measurement is plus or minus 0.05. Okay? So that is where we deduce the fact that the maximum possible error that you can have, either beyond the measurement or below the measurement, okay, beyond the actual measurement or below the actual measurement, the maximum possible error you can have is always usually equal to half of the what? Of the unit of measure. I told you what unit of measure is, right? The smallest division on the measuring instrument, the tiny ones. So the value of the smallest division is what we call unit of measure. So this is 5. So what is it? 5.1, which means it's every tiny line is representing 0.1, is incrementing by 0.1. So that's 0.1 is what we call the unit of measure. Half of it is the maximum possible error. So what did you learn so far? You learned so far, number one thing that you learned, or that I've explained to you, I believe you have learned, is the fact that the last digits of measured values is usually called the error digits, because most of the time the digits are usually approximate values, okay? So they are not exactly that value, but they are rounded off to become that value. So those values are usually the error values, okay? But then the maximum, then secondly, you learned about units of what? Of measure, all right? The second thing you learn about is the unit of measure. Then the next thing again that we'll talk about is that the maximum possible error, using this illustration, the maximum possible error you can have on a measuring instrument is plus or minus half of the unit of measure. Do you understand it now? So that is the three things that you have learned so far. Now, in the next video, we are going to be talking about possible error, which I've just spoken about. You can call it possible error or maximum possible error. But we want to talk about its relationship with what? With precision. And then in another video again, we'll talk about relative error and accuracy. So I'm going to split them video by video so that you can be able to digest them, and then you'll be able to connect what you learned earlier into something else. I don't want it to be too long and boring. All right? Physics makes people sleep. So I don't want a single lecture to be too long. And so I have to call it a day for this video. All right, don't forget these 4 things I always say. Number 1, you learn. Number 2, you try to understand what you learn. And that is why we always do this thing, breaking it down to your level of understanding so you can relate with it. Because whatever you understand is usually difficult for you to forget. Then number 3 is that you put into practice what you understood so that you can always retain that knowledge and then apply it to solve real life situation, because that's why you are in school anyways. Do you understand? And then number 4 is excellence. So you learn, you understand, you practice, and you excel. Don't forget the 4. If you are watching this on YouTube, please hit the subscribe button so that you can be the first, and on the notification bell also, so that you can be the first to know when we upload a new video on our channel. And then please just try and like it. And then you can put a comment also to just say at least thank you, or probably you don't understand a certain thing, and then we'll reply you and explain it to you, okay? And then please, if you need one-on-one explanation to over some concept being discussed, or some things are not so clear to you, I might not say all of these things in the other videos, okay? But just grab this. The phone number has been flashed there at a point or the other, so the phone numbers are there. You can also check the description below for the contact details. Please feel free to contact us. I will talk to you, and then, or somebody else also in our team will talk to you and explain everything to you in detail, okay? All right then. See you in the next video. Bye.